So this is where we left off last Thursday. So let me just put on my glasses, otherwise I cannot see what I'm looking at on the screen. Okay, let's just play these slides. Okay, so, okay. All right, if you remember what we learned about last Thursday's the mass transfer coefficient, or the way you calculate the interface concentration using film mass transfer coefficient. Okay, so the other small part of this is actually using the same calculation, but using overall mass transfer coefficient. So what you learned in the last week is actually how to calculate the interface values and the flux using film mass transfer coefficients. So film mass transfer coefficient is denoted by the small k. Okay, so let me just, oh, not that one. Let me just try to scribble on the screen, okay, so that I can actually see, or I can actually show you what I'm talking about. Okay, so what we learned about last week is the small k, ky, and also kx. Okay, small k. So what I want to introduce you today, what I want to introduce to you today is the overall mass transfer coefficient, which is denoted by capital K, like that. Okay, capital Kx and capital Ky. So this is correlations, or these are the correlations between the capital K, which is the overall mass transfer coefficient, and this is the overall mass transfer coefficient. This is also the overall mass transfer coefficient. This is for the gas and this is for the liquid. So this is the correlation between the overall mass transfer coefficient for gases, for the gas phase, and the liquid phase. So now you're introduced with the term M prime. Okay, so for the liquid overall mass transfer coefficient, you have M double prime. So in the next slide, I will explain to you what actually are these M prime and also M double prime. Okay, if in the question or in any situation you have or you will face in the future as an engineer, you want to assume it to be a gas controlling process, you will have to take the 1 over K prime X to be approximately or more or less the same as 1 over K, the small K prime X. So if it's mentioned anywhere, or you want to assume that it's gas controlling, so K prime X, which is the overall mass transfer coefficient, is actually the same as the film mass transfer coefficient for both gas and liquid controlling. Okay, so let's go to the next slide. Okay, what I want you to know is where to get those M prime and also M double prime and M prime. So this is the slope that you learned before, okay, in the last week. This is the slope for you to calculate K prime X over K prime Y. Okay, the calculation that you did the last week. So now you are introduced to this slope. So this slope is simply called negative K prime X over negative K prime Y. But for this slope, M prime and M double prime, M prime is used in the gas phase overall mass transfer coefficient, correlated to the both film mass transfer coefficient, and M double prime is actually used in the correlation between the liquid overall mass transfer coefficient related to the both of the film mass transfer coefficients. So if you're not given with the M prime and M double prime, what you have to find is you have to first plot the equilibrium line, And then once you get the point M, you can draw the line between M to point D and also between M to point E. So what you get what the slope that you get for this part of the graph is M prime, and for this part it would be for this part is M double prime, and for this part is M prime. Okay, so in order for you to do the calculation that we did last week, which is to find the interface concentration in overall mass transfer coefficient part of this of the topic, you have to use this correlation, and you have to like do the correction for k prime y for a case where diffusion of A through stagnant or non-diffusing B. This is the equation that you use. For the one that you have before, let me just go back a little bit. This is for equimolar counter diffusion. This is what you will use as the correlation between the overall and also the film mass transfer coefficient. But in the case where if it's for diffusion of A through stagnant or non-diffusing B, this is the correlation that you are going to use. And I know this looks quite complicated, and this is now involving the log mean values. No, not only this log mean value, now you will have a new log mean value that you have to calculate. So as for this part, which is the log mean value for the gas and also for the liquid at the interface, I have shown this in the last class, but now I want to teach you on how to calculate the 1 minus YA star M, which is the log mean value using the overall mass transfer coefficient. Okay, so this is for the equation for the gas part, and this is for the liquid part. So let's see how you can get this log mean value. So let's go to this slide. Okay, if you see, this is the equation, or not the equation, the log mean value, and this is how you calculate. Now you are introduced with the term of Y star A. So this is actually Y. How do you get your Y star A? Your Y star A is actually corresponding to the value of the bulk liquid composition. So as for bulk liquid composition, you go to the equilibrium line at point E, and then you go to the left and you will read the value for Y star A. That is for 1 minus YA star M. So all the values in here will be using Y star A. You won't be using the I value, which is the interface value. And the same thing for the X values. Okay, so what you get, you will get X A star or X star A from the value of YAG. YAG is actually the bulk concentration of your gas, okay, in the gas, bulk concentration of A in the gas phase. So you will go to the equilibrium line at point D, and you go down and you will see the value for X star A. So that's how you read it. Okay, all right. So in order for you to understand this better, I will be giving you some assignments. Okay, so sorry, I have to give you some assignments because you have to familiarize yourself with the calculation that you have to do for this part. Okay, so this is going to be your assignments. Okay, so you have to open your Gin Copley's book, the problem part at the back. If you have the old version, it's page 690. All right, so you have to do problem number 10.41 as well as problem number 10.42. Okay, so okay, so now I'll continue with this. Okay. Okay, so this is your assignment that you have to do for this part of the topic. Okay, so please submit in e-learning. Okay, the due date is by the 29th of October. You have to submit in I will open the, what do you call it, the link. Okay, I will add the link in e-learning, so watch out. If I haven't added the link, Ayman, please alert me so that I know that you have not got you have not received or you have not seen the link in the e-learning. So I think that's all for mass transfer topic. Okay, so in the next class or in the next recording, I will be covering the next topic, which is humidification. If I cannot post the recording today, I will post the recording on Thursday, and we will have a synchronous class on next Sunday. Okay, so bye everyone. Jangan lupa buat all the assignments. Okay.